So far we have provisioned the servers, and then we set up Cloudera Manager, and using Cloudera Manager we have set up several big data services such as HDFS, Yarn, MapReduce, Spark, Hive, etc. On top of these things, we also have other Hadoop ecosystem services such as Oozie, Pig, Sqoop, and also a Cloudera distribution service which is nothing but Hive. First, let us set up Oozie, Pig, Sqoop, and also we will focus on setting up a few as part of this topic. That being said, for Oozie and Hive, we have dependency on database. We have set up a database on Big Data Server 1, and as part of setting up the required prerequisites for our cluster, we have set up database for Oozie as well as Hive. However, our database is set up on MySQL, which is installed on Big Data Server 1, and we want to set up Oozie server on Big Data Server 3. And hence, we need to have a connector from Big Data Server 3 to Big Data Server 1. Otherwise, we will not be able to set up Oozie service. So first, let us log into Big Data Server 3 and then set up this MySQL connector Java using yum, and then we'll take it further. So here, I am connecting to gateway node. Once we are on gateway node, we can actually run this sh command to connect to Big Data Server 3. Once you are on Big Data Server 3, you can say sudo yum -y install MySQL-connector Java and hit enter. It will take care of installing the required JDBC jar file to connect to the MySQL database from this server. As the connector is installed on Big Data Server 3, now we can actually go to the browser and go to Cloudera Manager, expand this, click on add service, and then choose Oozie here, and then hit continue. Here you need to choose what all type of jobs Oozie workflow can submit. So if you want to submit Hive as well as Spark jobs using Oozie workflows, then you have to choose this. If you only choose this, then you will not be able to run Hive queries or Spark jobs using Oozie workflows. That being said, let us choose this where we have Hive, Spark on top of HDFS and Yarn, so that using Oozie we should be able to submit Spark jobs or run Hive queries. Now we can hit continue. You have to expand this, and as per our topology, we are supposed to set up Oozie server on Big Data Server 3. So let's choose this and click OK, and then hit continue. Our MySQL server is running on Big Data Server 1. We have already set up database for Oozie. The database name is Oozie, username is Oozie, and password is ITversity. Now we can actually say test connection. So test connection is successful, and hence we can hit continue. You can review changes. So there will be a directory called /user/Oozie in HDFS. All the files with respect to Oozie will be preserved in this location. It is called as Oozie service system lib path, and hit continue. And then it will take care of setting up all the required components, and also it will start the Oozie server on Big Data Server 3, and also it will actually install the share lib in HDFS. You can actually connect to the gateway node and run hadoop fs-ls user Oozie and hit enter. You can see that there is a directory called share under this user Oozie main directory, and if you actually dig further and go into the share directory, you have lib, and within that lib you will have subdirectories or jar files which are relevant to the Oozie workflows. So let me copy this one also and then run hadoop fs-ls and paste it. You can see here for each and every service there is a subdirectory, and again within that subdirectory will be finding several jar files. So these are the jar files which will be used when we actually run Oozie workflows. -R for recursive. You can see bunch of jar files in this location. Now the Oozie service is set up on the cluster. We can hit on continue and finish. So it took care of setting up of Oozie for us. Oozie also have web UI. You can click on this and you can actually click on this. It might not work because shuttle is not going on right now. As Big Data Server 3 is pointing to private IP on the cluster, it might not work. So first what we have to do, we have to take care of running shuttle. Once shuttle is started, as we have already updated etc hosts by pointing to private IPs, and as we are using Big Data Server 1 as proxy, now if we refresh this, it will actually bring up the web UI of Oozie. However, it says Oozie web console is disabled, and it actually depends on something called ext.js library. So we need to set up ext.js on the server where Oozie server is running, which is nothing but Big Data Server 3 in this case. And then we have to enable Oozie web console by going to Oozie configuration, and then if we refresh, it will work fine. So let me connect to the gateway node here. Once we are on gateway node, we can actually connect to the server on which Oozie server is running, which is nothing but Big Data Server 3. Once we are on that, we can actually download the ext.js from Cloudera archive. I have already documented as part of the material. So we just first have to install wget and unzip on this machine. Now using wget, we can actually download this zip file. You need to ensure that you are actually downloading compatible zip for the version of Cloudera you are setting up. For a very long time, this 2.2 is fine. If it didn't work, then you have to search in Cloudera archives for the appropriate zip file which is compatible with whatever version you are trying to set up, and you can take it from there. However, I am using this wget command and it will download the zip file for us. Now we can actually run unzip against this. This unzip will actually create a directory called ext-2.2 in this location. Then either you can copy or move this directory into varlib Oozie. You have to use sudo for this. I'm actually doing move here, and the target location is nothing but varlib Oozie. Once you do that, you have to change the ownership of that directory to Oozie. Once the ownership is changed, now you have to go to Cloudera Manager, go to configuration, search for web console, save changes here, refresh this page. It will actually ask you to restart the Oozie server. So just click on that icon and then click on restart stale services. Make sure to choose redeploy client configuration and click on restart now. It will just take a moment and it will actually redeploy the client configuration and restart the server. Once it is restarted, then we can actually go back to the Oozie service and click on web UI, and this time it should be open without any issues. So it took considerable amount of time, so I just expanded all these things and it seems to be going on smooth. So let us wait for a few more seconds and then we should be able to click on finish once it is active. Now everything is successful, so we can click on finish and then click on Oozie, go to configuration and then click on Oozie web UI. And now Oozie web console is opened without any issues. So once we actually submit Oozie jobs on this, you will be seeing details about those jobs here. We will review the properties and also run Oozie workflow at a later point in time, but the setup is successful. You can also log into the Big Data Server 3 and then go to var log Oozie and then run lsfnltr here. You can see a log file associated with our Oozie server component, which is nothing but Oozie server. That being said, as Oozie is set up successfully, now let us go ahead and set up Pig and Sqoop as well. So with respect to Pig and Sqoop, it is very straightforward to set up those things on our cluster. Both use HDFS as file system and MapReduce for processing engine. There are no server components for either of them. And if you actually expand this and click on add service, you will not be able to see the pig here because pig is already set up as part of setting up of our environment. You can directly go ahead and run pig jobs on our cluster from any node in our cluster, including gateway node. As part of the installation using parcels and packages at the step 1 itself, pig is automatically set up for you. Pig is nothing but bunch of jar files, and those jar files are already deployed for you. And when it comes to Sqoop, you can actually choose this and hit on continues. Even though there is something called Sqoop 2, it is supposed to be better than Sqoop 1, but it never got traction because of too many issues and the complexity involved in setting up of it and also running jobs using it. And hence, Sqoop 2 has been deprecated and will be removed from CDH in a future release. So keep that in mind. Even though Sqoop 2 is available here, it will not be used that much, and also we are not going to cover Sqoop 2 as part of our course. We can hit continue here and then choose the hosts on which you want to configure gateway for your Sqoop. Again, there are no server components with respect to Sqoop. We just need to configure gateways. And we'll be configuring gateways on all the hosts in our cluster and click on OK and hit continue. It just need to deploy the properties files on all the nodes in the cluster so that we can actually submit Sqoop jobs from those nodes, especially from the gateway node. We can hit continue and then finish. Even Sqoop setup is done. Now it is time for us to set up Hue. So when it comes to Hue, we want to set up Hue server on Big Data Server 1, and we have already installed MySQL connector earlier itself because even Cloudera Manager, which is running on Big Data Server 1, is using the same MySQL server for the database. As we have already installed the MySQL connector, we need not install MySQL connector on Big Data Server 1 on which Hue server is being configured. That being said, now we just have to go to Cloudera Manager, click on add service and then select Hue here and then hit continue. So depending upon all the services you want to use as part of Hue, you have to select appropriate one. So in this case, I want to choose this because I want to run Impala queries, Hive queries Oozie jobs, Spark jobs, etc. from Hue. That's why I'm choosing this and I'm hitting continue. With respect to server, we want to set it up on Big Data Server 1, so I'm choosing this. As of now, I'm not setting up any load balancer. I'm deselecting this and clicking on OK and then continue. Our database is running on Big Data Server 1 itself, and hence we don't need to change anything here. We just have to give the database name, which is nothing but Hue, username Hue, and password ITversity. So all these databases such as Hue, Oozie, etc. we have set up even before we installed Cloudera Manager on our cluster. So all these things are already available. That's why when we click on test connection, we are able to connect to the database as we have manually created earlier. So test connection is successful here, and hence we can hit on continue. It will take care of installing the Hue server on Big Data Server 1, and it will start the Hue server. Once Hue server is up and running, we should be able to connect to Hue Web UI as long as the port is open in the firewall. The default port number on which Hue will be running is nothing but 8888, and we need to open that port number in our firewall rules so that we are able to connect to the Hue server. So the way you have to do that is you have to go to your respective environment and then go to the respective server on which Hue is running. In this case, it is Big Data Server 1. Go to network details. Depending upon the environment, the steps might change, but fundamentally you have to open a port if it is blocked by firewall. That being said, now as part of web ports, I'll be opening 8888 as well, and then let me hit on save. Once it is saved, we can go to this Cloudera Manager, click on Hue, and then Web UI. Okay, accidentally the Hue is set up on both Big Data Server 1 and Big Data Server 6. It is not correct. We have to remove from Big Data Server 6. We will take care of it in a moment. You can see here, it have launched the Hue Web UI. We will actually get into the details at a later point in time, but for now, Hue is successfully set up on Big Data Server 1, but accidentally it was set up on Big Data Server 6 also. The way you can fix it is by going to instances and then select this Big Data Server 6 and then stop and then delete. And we are good to go. We have Hue server running only on Big Data Server 1. We will validate once again because we have deleted one of the servers. It might impact the existing one. To make sure that it is not impacting, we will just open the web UI and see if it is coming up without any issues or not. You can see that it came up without any issues, which means our Hue setup is also successful. So we have set up all the 4 services, Oozie, Pig, Sqoop as well as Hue on our cluster using Cloudera Manager.